Good morning. Today what we're going to do is take a look at Unit 7, Calculus 30, derivative of sine and cosine functions. I'm going to start with the sine function in this video, and then I'm going to do the cosine function after. What you notice on the first page here are some things that you would have learned in Pre-Calc 30 that are going to come back and be handy for us. Basic sine curve, a basic cosine curve. When you take a look at the unit circle, all of the identities that were part of Pre-Calc 30, all of those play a role at some point in time in looking at the derivatives of trig functions. So today what we'll start with here is how do we come up with the derivative of a sine function? Here's the proof. So if we were to start with a function sine x, going back to the definition of a derivative, that limit process, y2 minus y1, applying it specifically to the fact that we have a sine function, taking a look at expanding part of the function there, the limit, this portion of it, here that is part of the limit process, is similar to the sum identity, and so you'll notice that that's what they replace here is the sum identity for sine, and that progresses here where they just do some regrouping, factoring, and separating. Again, they have rearranged, they've pulled out sine out of the first two terms and then gave each trig ratio its own denominator. Now this next part here is something that we haven't looked at yet. Applying the limit h is equal to approaching 0 is difficult in a couple of these cases here and here because we still have a denominator h and we can't have that h being 0. So what the proof does here is they graphically evaluate what the limit is as h is approaching 0 for both of these expressions. And if you take a minute and look at the graph of each of these equations or functions or expressions, the first one here approaches 0, and the second function here approaches 1. And so when you take the limit, you're simplifying it down to cosine. So basically what they're saying here is if you start with a sine function, the derivative, you're going to essentially change it to cosine of the same angle, and then you would be taking the derivative of the angle. And so we'll practice those two steps when we take a look at a few examples. So starting off here, we've got a function sine. The angle is 4x cubed. So if we were to take derivative, again, the rules are we change it to cosine of the same angle, and then we take the derivative of the angle. So derivative of 4x cubed, 12x squared. More often than not, you're going to see the simpler polynomial function placed first, and then your trig ratio, the one that's just a little bit more complicated, next. So again, the two pieces that we have here, the first part was we change it to cosine of the same angle. And then the second step that we see here is the derivative of the angle. And that's the steps that we're going to follow for a sine function. Second example here, same idea. To find the derivative, we have an extra 2 multiplied out the front, being that's just a number, no big deal. Just tack it on there. But we'll change for sine of pi x to cosine of the same angle. And then we'll multiply to the derivative of the angle, which is the number in front of x. So we would have pi. Again, you can expect that they're going to move the pi out the front with the 2, and then cosine of pi x. Now I'm putting the angle in brackets. It's important that I'm very clear as to what the angle is just a little process that I do to make sure that I have everything sorted out. Another one here. Now, one of the differences with this is now that we have a power here, one of the first and foremost things that we need to keep in mind is what that power of 3 means. Is that when we take a look at their sine function, sine of 5x, the entire function is being cubed. So when we look at this function now, essentially what we have is a chain rule. So when we jump into taking the derivative, following the chain rule, the power is going to be multiplied out the front. The power drops by 1, and we keep the inside the same. Now, when I go to take the derivative of the inside, now I'm dealing with a trig function, changing it to cosine of the same angle, and then the derivative of the angle is going to become 5. So we've got a few pieces that are being multiplied together. Your 12, your 5, multiply and give us 60. We're going to have that cosine of 5x, and we're going to have the sine of 5x, and it's squared. I'm just going to put it back there since that's the way they started. So all of these pieces are being multiplied together. So we have to be careful with any other rules that can pop up, like this chain rule. In this particular example, now we are seeing an exponent because it has the variable part of this first part being multiplied to this sine function. Now I'm looking at a product rule. Product rule, but it also now involves exponents as well as the trig ratio. So jumping into the derivative, I have to remember my rules here. I'm taking the derivative of the first, which is the exponent. So I have to make sure that I am following my 3 steps, which said same function. And then the second part was natural log. It was base e of the same base, which is e. And then the derivative of the exponent, which is 6x. So this part here is derivative of the first times the second. So sine of e to the power of 2x. And there is the g part. Plus the first. Now we'll multiply it to the derivative of the second, which is our trig ratio. So now we're back to changing it to cosine of the same angle times the derivative of the angle. And the angle is an exponent, so I've got to go back to those exponent rules, which were the same function, log in base e of the same base, which is e, and then the derivative of the exponent. And so there's a lot of little pieces that we have to follow as we're going through and doing this. And so it is important that we are okay, not only with the fact that we have a product rule, but we involve exponents, trig ratios, all sorts of things. So I've got lots of things to think about how I can clean it up. Of course, natural log of e is 1, so I don't need to worry about those 2 pieces. So it looks like in the beginning part, I have multiplied. Now I'm going to try and reorganize it a little bit. Simple little 6x in the front. I have the e with the 3x squared. And then I've got that little bit more complicated looking e, sine of e to the power of 2x. The second part here, I've got the simple 2. I have the e with a 3x squared. I have an e with a 2x. And then I have a cosine of e to the power of 2x. Now it's important that we understand that a cosine and a sine function, they are, I guess, complete, if you want to say, with an angle. We can't separate sine from this. Because what I'm going to do in the next step is I'm starting to see some factoring that I can do to simplify it in some way. So if I go through and I look at the pieces that are common, I have a plain old set of numbers here, of which 2 is common, not the x. But I do have the e to the power of 3x squared that is part of both functions. I don't have anything else that's common to both. So we'll take a look at what's left over. I have a 3x from the 6x. This e is gone, and I would still have a sine e to the power of 2x in the first term. The 2 is gone. This e with its 3x squared exponent is gone, so I have this e with a 2x, and then the cosine e 2x is left over. That's as simplified as I'm going to get. So we have ourselves a derivative using the product rule with a few others mixed in. And this last example really isn't much more complicated. I think the last one is by far the most complicated. This one, just recognizing that a radical is going to have to be changed to a power before I do anything. And again, when I look at this with the power over the entire sine function, we have ourselves a chain rule again. So when I start to take the derivative, the power has got to come down out the front and multiply to the 5, making that negative 5 halves. The power is going to drop by 1, and the inside stays the same. Now we'll take the derivative of the inside, which changes to cosine of the same angle, and then derivative of the angle. Simplifying this, my 2's are going to cancel out. I don't have to worry about those. I have a negative 5. I have this cosine 2x also on the top, and my negative exponent, I'm going to put her back down in the bottom. Sine 2x, and why not? I can change it back to a radical instead of the power of a half. And there we have our derivative. So that takes care of how to find the derivative of a sine function. I'm going to do a separate video for cosine function, but you can see that we're dragging back all the rules that we've learned before, chain rule, product rule, exponents, so we have to be prepared for everything. That's all for today. Thank you.